In this lecture, we're going to look at C++ lambdas. What are lambdas? Lambdas are a construct in C++ that allows you to define functions in line. You define them in place and you can use them right away. Another feature that lambdas provide is to be able to capture variables in the context. I know this might not make sense, but we're going to see that and you're going to understand this by the end of the lecture. To put things in context, let's head to Qt Creator and create a project to show off these features of lambdas. Okay, here we are in Qt Creator. We're going to create a new blank C++ project. It's not a Qt project. We're going to choose non-Qt project here and choose plain C++ application. We're going to give it a name, which is 2 lambdas. We're going to save it in a location on our drive here. Choose the kit and finish. Okay, so I just said that lambdas allow you to define function in place right away. Right now, our code is outputting hello world here. What we're going to do is put this in a lambda function and call it right away to do the same thing we're doing here. So you see hello world is outputted. C++ lambdas have a structure you have to follow. They are like function signatures, the rules you have to follow to define them. And on the left, you have a capture list that is inside these brackets. You have a parameter list. That is the parameters you want to pass to your lambda function. And on the right here, you see that we have a function body. Okay, now that you know the signature of lambda functions, I'm not sure if you call this a signature, but we're going to do that here just for the sake of understanding what is happening. So let's define a lambda here. So we're going to put brackets here. It's not going to take any parameter. And we are going to do the function body here. Okay, so inside we're going to put our good cout statement here. And by now, this is a lambda function that we have defined. What does it do? It says hello world to the console. I know this notation may be cryptic to you, but when you see a notation like this, know that it is an inline function that we are defining and we can call it right away. So now that we have defined our lambda here, how do we call it? There are two ways we can call it. One is by giving it a name and calling it as a function, and the other is calling it right away after we define it. So let's first give it a name and call it. We give it a name like this. So we can say auto func equals our lambda function here. Okay, remember our lambda function starts from these brackets and it ends here. Okay, now that it has a name, we can call it like we call any C++ function. So we're going to say func like this. Okay, if we run the application, you might try to guess what we're going to see. We're going to see hello world. Okay, let's run it. Hello world. Okay, if we didn't call func here, let's see what we get. Nothing. Okay, so you have to call the lambda to actually get it to do something. Okay, now that we've seen the first way to call a lambda, I'm actually going to put this back here so that you have it for reference. And I'm going to comment this out to show you the second way you can call a lambda. Okay, so let's copy our lambda function here and put it here. The second way you can call it is by putting a set of parentheses after you define it. And if this lambda happened to take parameters, you could put in the parameters that you're calling it with. By now, if you run the program, we're going to see hello world here because we called the lambda function directly after defining it. So let's run the application and see what we get. Hello world. So to make things clear now, I'm going to define a lambda function that takes two parameters because we haven't worked with parameters right now. So to make things more clear, I'm going to comment out with the information here. So give lambda function a name and call it give call lambda function directly after definition. Okay. Now what we're going to do is to define a lambda function that takes parameters. Lambda So how do we do that? So we're going to put the brackets here, and we're going to put in a parameter list. It's going to be 2 integers because this function is going to do the summation of 2 integers. Okay, so we have our parameters, and we put in a function body here. And what it's going to do, it's going to say the sum of A and B is the sum of A and B. Okay, so we put space here. So it's really going to give us the sum of A and B that we pass in here. So to call this lambda function, we can call it directly as we did before, but this time we're going to pass in the 2 numbers that we want to add. Okay, so we say, for example, 7 and 3 in here. Okay, if you run the application, what is going to happen? Try to give it a guess. Okay, let's run it and see if you got it. Boom, A plus B equals 10. We defined a lambda function here, and we directly called it by giving the parameters that we want to call this function with. I hope this makes sense. We've defined a lambda function, we know how to call it. So how do we capture the return value if we want this function to return a value? For example, what if we want this function not to print the sum, but also return it so that we can use it in other places in the application? Okay, to show that off, we're going to comment this out and state what we're going to do. Define a lambda that returns something. Okay, so we're going to take this method here because we can copy it directly to save some time. This is our usual method. So what we're going to do is specify a return value for our lambda here. And the way you do that is by putting a dash and a greater than sign here and specify what this lambda function returns. So this is how you specify the return value. I know this is cryptic. It's not easy to understand for first-time users, but as you use it, you start really liking it and using it all over the place in your code. So what we can do now is return A plus B. Okay, right now, if you run the application, you're not going to see anything. Let's run it to prove our case. Nothing. Why is that? Try to think about that. We are actually defining a lambda function. We are calling it here, but we are doing nothing with the returned value here. So to be able to do something with the return value, you may want to capture it. And one way is to define an integer and call it sum, for example, and assign the return value of our lambda function to it. And right now we can output the sum here and say the sum is whatever was returned in sum. Okay, if we run the application, we're going to see our sum. The sum is 10. Okay, this is good. You see that we are doing this in 2 steps. You can also say, okay, I don't want to define this thing here. I want to use a lambda function directly inside my output statement. So I can copy my lambda function here. Let's get rid of this column and replace sum with our lambda function. Okay, I know this looks cryptic, but it's going to work. Run the application. The sum is 10. I hope you really like the way lambda functions work. By now you haven't really admired how good they are, but just knowing the syntax and how they work is going to open the world to how you use them in your real life project. We're going to be using one aspect of lambda functions with signals and slots in Qt. That's why I'm explaining them here, but that's not the only use you have for them. You're going to use them elsewhere in your C++ development. Okay, now we know a great deal about lambda functions, and I think we can go up and update this signature of lambdas to take into account the return type. Okay, so this is a more complete signature for lambda functions. Let's go down here and introduce a very strong concept about lambdas, that is capture lists. Okay, we've said that we use capture lists in lambda functions, but we haven't really used them so far. Okay, so let's comment this out and say that we are going to use capture lists. Capture lists give you a way to capture the variables that are in the current context. What do I mean by that? So let's define two values. We're going to define int a equals 7, int b equals 3. Okay. What we want is to define a lambda function and give it access to these values so that it can use them. So let's define a lambda function here. So I'm going to put in a capture list, and I'm going to put in the parameters. I'm going to call this number 1, number 2. And we want to do something inside this lambda function. We're actually not going to give it any parameters because it's going to capture the numbers here. Let's try and output these values inside the lambda function. How do we do that? See out a is a, for example. Okay, and to test this, we're going to try and call this lambda function. So let's run the application, and it's going to complain that a is not captured. Okay, so we can't have access to the values outside the scope of this function. What capture lists allow you to do is to be able to use things in the scope that is outside your function. I hope this makes sense. So what we're going to do is put a and b into the list of variables that we want to capture inside this lambda function. And now if you run the application, you're going to see that it's going to work. It's going to tell us a is 7. A is 7 here. Okay, we can also access b the same way. Say b is b. Okay, run the application. A is 7, b is 3. This is all capture lists are really about, capturing context. You can only capture things that are in the context where the lambda function has been defined. For example, you cannot capture something that is outside the main function here. It's impossible to do. And using capture lists, you can do all kinds of crazy things. For example, you can say a plus b is the sum of a and b. Okay, so let's say this. See out a plus b equals a plus b. Run the application. Boom, a plus b equals 10. We are capturing these things. Now that you know how capture lists work, I want to introduce another concept of lambda functions. It's a concept that applies to other functions too, but right now we're going to explore that in terms of lambda function, and that is capturing by value. What do I mean by that? Okay, I'm going to define an integer. I'm going to call it c. It's going to be 42. And I am going to define a lambda function to access this value. Okay. I'm going to capture it so that I can access it in there. And I'm going to say cout the value of C is C. Okay, now that I have this, I want to call this method, but I'm going to do that inside a loop, and I'm going to modify C so that we can see what is happening inside the lambda function. If this doesn't make sense, bear with me, you're going to see that. So we're going to do a for loop. So we're going to say for int I equals 1, I less than 5, let's say, for example, and I plus plus. And we're going to call func to access the value using the lambda function that we have here. And we're going to increment C. Okay, we're going to say C equals C plus 1. And before we do anything inside this method, we should output the value that we have in C outside the function. So we say the outer value of C is C. I hope you understand what we're trying to do here. So what we're doing, we're defining a variable outside the scope of the lambda function. We are defining the lambda function to access the value from the outside context. And after the lambda function, we are looping from 1 to 5, outputting the value of C from the outside. And here we should clarify that it is inside the lambda function. We are looping to say that the outer value of C is C, capturing it and incrementing it. So if what we want to see is that the value that is on the outside is the same value inside the lambda function. And let's run the application to see this. Okay, I'm going to try and explain this. Okay, so if you look at this, you see the outer value is 42, 42, but when we increment, the inner value doesn't change. You see, inner value is always 42, even if we increment this on the outside. And this implies that the lambda function has made a copy of the outside value. Okay, it's not working directly on this variable, it's working on a copy of it. And this is critical to understand when you're working with lambda functions. Otherwise, you're going to end up with errors that are hard to debug. When you pass a value like this, it is a copy you have inside the lambda function. It's not the original value. Okay, this is what I'm trying to explain here. But if you want to pass the original value in the lambda function, you can pass it by reference. And that's what we're going to see next. Let's comment this out and say capturing by reference. Okay, it is the same thing basically, but you change only one thing to have this thing work the way you want. All you have to do is put this pound character in front of the value that you want to capture in the capture list. And there you are working on the original value. What you are actually passing in here is the address of this C variable in memory. And whenever you change it, you are changing the value in that address. This is like a pointer if you have ever worked with pointers in C++, but you don't need to understand pointers to work with this. Okay, so what do you think we'll see when we run the application? Let's run it so you can see. Outer value 42, inner value 42, outer value 43, inner value 43. You can see that now inside the lambda function, we are accessing the real outside value. Okay, there are two things I want to introduce before we wrap up this lecture. and that is capturing everything in the context. Okay, let's comment this out. Copy our code that we're going to use, and we want to capture everything by value. So the way you do that, you put an equal sign in here, and that's all. So let's run the application. We should have our variables captured by value by now. So 42, 42, 43, 42, 44, 42. You see the outer value is changing, but the inner value is not changing. But we are capturing everything in the context. So if we happen to have a D value in here that is equal to 6, we should be able to use it inside our Lambda function. Okay, so let's actually do that. The inner value of D is D and D, and we should be able to access it. Okay, D, we are accessing D because we captured everything in the context of this main function. So if you don't want to capture everything by value, you can also capture that by reference. So let's comment this out. And copy our code as we did before. And to capture by reference, you might guess that it's easy too. It really is about using this pound symbol. Okay, by now you have captured everything in the context by reference by putting this thing in here. Let's run it again. We can capture C and D here. Okay, and you see that now the inner value and outer value are changing together because we are capturing by reference here. Okay, so this covers all we set out to do in this lecture. In the next one, we're going to look at signals and slots and different ways you can connect them to make your application do things actually. I'll see you in the next lecture.